Okay, I have started recording. All right, so the class has started. First of all, let me start sharing the screen with you so that I can show you something on Moodle. Okay, there's the screen. So this is Financial Management 1, as you see, and at the very top of all this big page on Moodle, at the very top you see midterm survey. Okay, can you guys please take a minute? Not right now, sometime over the next 2 or 3 days. Don't do it right now, but over the next 2 or 3 days, just answer these questions on the midterm survey. It's only 5 or 6 questions. It's only going to take you 1 minute. Okay, please do that when you have time. More people are joining. Okay, joining the class. Okay, now we can jump to another window. Let's have a look at Excel. Let me find it. Where's my Excel? Over here. Okay, so to summarize, over the last several weeks, we've learned how to use present values, that's PV in Excel formulas. We've talked about future values, that's FV in Excel formulas. We've learned how to use rates, the interest rates, discount rate, cost of capital. All those are different names for the same thing, which is the interest rate. And in Excel formulas, we use the formula rate for that. And over the last several weeks, we've also looked at how to use this NPER formula, which stands for number of periods in your investment or in your loan that you're calculating something for. Okay, so we've talked about these 4 variables for 3 weeks already. Okay, and last week we introduced one more variable, which is the PMT. Okay, so PMT, as we introduced last week, represents some sort of regular payments. Okay, some sort of regular payments at regular intervals. So the payment that is of the same amount and also takes place at a regular interval. Okay, actually it also would have another name. Okay, annuity, regular payments over a regular interval of time. So annuity is this other name for regular payments over a regular period of time. Okay, so how annuity looks like on a timeline is something like this. Let me take a minute to start drawing here. Let's say we have a timeline on Excel like this. And let's say this is time 0. This is 1 year later, 2 years later, 3 years later, 4 years later, and so on. Okay, and to represent annuity, to represent a regular payment, maybe you are buying an investment that will promise you a regular payment for the next 4 years. Let's say it promises to pay you 20,000 over the next 4 years. If the investment pays you 20,000 over the next 4 years, that would be a positive cash inflow into your pocket. So I have regular payments every year over here of the same amount of 20,000. Here is an example of an annuity. Okay. And for example, if you manage to pay, say 72,400 for this investment. So basically you are buying the investment, let's say from a bank, where you give the bank 72,400 right now, and in return the bank pays you 20,000, a 4-year annuity, okay, over the next 4 years. Then this is how this exchange between you and the bank would look like on the timeline. Okay, let's try to calculate something based on this example. Okay, first let me see if I can find these variables on this example of the timeline. PV. Let me go back to you guys. Can you tell me which of the numbers is PV here? Any one of you just turn on the microphone, shout out the number.
724.
Thank you. Yes, 724. So to remind you, PV stands for present value, but actually we might have examples where, let's say, a relative invested for you 10 years ago and you are now going to cash out this investment. Okay? So in this kind of a strange example, today is when you are receiving the money, but original investment was made 10 years ago. So although PV, the full name of PV is present value, actually what it stands for, actually what it means is any kind of original investment. Okay, so in this example, yes, negative 72,400. In this example, we don't have any separate values that will come in addition to the regular payments from the bank into your pocket. So FV is simply zero. FV is future value, and as you know, is just some sort of a separate, another amount in addition to any regular payments that is received or paid at the end of the investment timeline. Okay. A rate, I don't see any rate here, so perhaps that's the thing that we're going to calculate. NPR, as I said, stands for number of periods. Clearly we have 4 periods here, so that's 4. PMT, the only number we haven't used is 20,000, so that's the 20,000 over here. You see? So even if I don't give you the actual question, right? If you understand what's going on and just relate the numbers you see on the timeline to these 5 variables, you can see what's missing. So it's obvious we can calculate the rate here, right? So to do that, you already know, we just hit equals. Everything is really easy as long as you understand the question. All the calculations are done by the computer for you. Type rate, open the brackets, and you even get the hints of what to enter here. NPR, I just click here, comma, PMT, I just click here, comma, PV, click here, comma, FV. There's nothing in addition to these regular payments that I receive at the end of the period. So that's 0. Close the brackets and hit enter. Looks like it's 4%, but let me remind you, we like to have more precise answers. So you can use this button to see more precision here. It's actually 4.12% per year, per period. Okay. So of course, for your exams, 4 would be incorrect. 4.12 would be correct because we want to have precision. Okay. So that is generally what is an annuity and an example of calculating a rate for an annuity of 4 years. Okay. But there are 2 kinds of annuities. Okay. So there are 2 kinds of annuities. There is one kind of annuity over there, another kind of annuity over there. There is ordinary annuity, okay, where the regular payments take place at the end of the periods. Okay, so this example that we've looked at is an ordinary annuity. We see that the first 20,000 is paid at the end of the first period. The second is paid at the end of the second period, and so on. So the last fourth 20,000 is paid after you finished waiting for 4 years. Okay, but there's another kind of annuity, which is called annuity due. Okay, so let's put the full name here. That's ordinary annuity. And this is called annuity due. That is the annuity where the regular payments take place at the beginning of the periods. Okay, So how would it look like on the timeline? Let me try to copy this. I wonder if it can be easily done. Very good. So an annuity due in this example would look like this. Just simply move these regular payments by one period to the left. You see the first 20,000 in this example is paid to you at the beginning of the first year. So the very beginning of the first year is today, right? The second 20,000 is paid to you at the beginning of the second year. The very beginning of the second year is same as the very end of the first year, so that's where the payment takes place. And the last fourth 20,000 is paid to you at the very beginning of the fourth year. So it's fourth 20,000 and fourth year, but the very beginning of the fourth year is more or less the same as the very end of the third year. So this is how an annuity due would look like. Okay. So there it is, and let's calculate something else to show us the differences between an ordinary annuity and an annuity due. Okay. So let's have another example over here. Zoom out a little so I can have a longer timeline, a little longer, more years if they can fit. That's today, 1 year from now, 2 years from now, 3 years from now, 4 years from now, 5 years from now. And let's say it's an investment, it's an annuity, where the bank promises to pay you whatever, let's say 15,000 5 times. Okay, I hear something. I think somebody's joining. Admit. Okay, we have 27 students in this class. I think we don't have as many people enrolled. I'm not sure where the people are coming from. That's okay, I guess. So anyway, we're looking at the difference between annuity due and ordinary annuity. Okay. So for that, we're going to look at this example. We have an investment lasting for 5 years. Okay. And as an investment, the bank promises to pay you 15,000 5 times to you. Okay. And the way this investment looks like on the timeline, we see there are 5 payments of 15,000, and they start at the end of year 1 and they finish at the end of year 5. So this is an ordinary annuity. This is an example of an ordinary annuity. And let's say, for example, the current interest rates on the market per year is whatever, let's say 6%. Let's say 6%. Let's say in addition to these payments, the bank doesn't promise to give anything else to the investor. So at the end of year 5, the future value, which is an additional payment at the end of the investment lifetime, in addition to any kind of regular payments, is 0 in this case. Okay. So let's say the question is, how much are you happy enough to pay for this investment? Happy double P, right? So that will depend on the interest rate. That will depend on the future cash flow. And if you do buy this investment right now, you'll have to pay for it right now. That will be the original payment at the beginning of this investment lifetime. So what we have to calculate is, of course, PV. PV is our unknown. Okay, so let's try that. Equals PV, open the brackets. You already know how to do that. Rate. Click here, that's 6%. Or you could simply type 0.06. Or you could simply type 6%. The computer would understand all of those. Okay. I like the decimals because there are some strange formulas. Later on we'll talk about different types of interest rates where the computer doesn't really understand the percentage sign. So just stick to the decimal places and you'll always gonna be fine. Okay. Comma, for number of periods, we have 5. Comma, for PMT, we have positive 15,000. Comma, for FV, we have 0. Okay. And now we're not going to ignore this one more hint over here. Okay. Come a bit closer to the screen if you cannot see it, but it says type. It's a very small thing over there. And what it refers to is this different type of annuity. Is it a regular annuity or is it annuity due? Okay. When you just ignore it and close the bracket, okay, the computer always thinks that it's a regular ordinary annuity. So for ordinary annuity, we just put 0 for the type. As you see, if you type 0 there, it says end of period. If instead you type 1, over here for 1, it says beginning of the period. Okay. So far we've never talked about annuities due. We've just ignored that last hint, which says type. It actually refers to what kind of annuity is there. Do the PMTs happen at the end of the periods, or do the PMTs happen at the beginning of the periods? Okay, now for this particular example where we compare ordinary annuity and annuity due, we don't ignore that hint. In this case, it's 0 because it's ordinary annuity, and hit enter. We see that the value of this investment right now is over 63,000. Okay. Now let's have a look at a very similar example with annuity due, just to see the difference. Control C, Control V. Let me move these payments one period to the left. So everything is the same. All the numbers are the same. The only thing is that these regular payments happen at the beginning of each period. There are still 5 regular payments. And even though the last payment happens at the end of year 4, NPER is still 5, because there are 5 regular payments. It's just that the 5th payment is made at the beginning of year 5. So it's kind of the same as the end of year 4. Okay. So this is actually annuity due. So let me rename it. This is an example for annuity due. Let's try to calculate PV over here and see if there is any difference. And maybe that will also help us to understand something about PVs, understand something about difference in different annuity types. So equals PV, open the brackets, same rate of 6%, same NPR of 5, same PMT of positive 15,000, same 0 FV. This time for type we have 1, that's annuity due, and PV is going to be bigger, bigger, bigger. Why? Why? Because when you discount the future cash flows, if cash flow is far away in the future, then the value of that far away cash flow today is very small. For example, if I promise you 1000 NT 20 years later, so I come to you today, right now, and say, okay, I promise to give you 1000 NT 20 years later. Is that promise very, very valuable? Who knows what happens in 20 years, right? Who knows what happens in 20 years? Who knows if I will be able to give you that 1000 NT 20 years later, okay? So when you talk about far away, the future cash flows are valued less when there is longer to wait. And for annuity due, as opposed to regular annuity, all of these payments come a little bit closer by 1 year. So the value of all of them today is going to be a little bit greater. You see? So PV is going to be greater for annuity due rather than for ordinary annuity if all the other numbers are exactly the same. Okay? So let's come back to you guys. Stop sharing. So far so good. Any questions? If you got any questions, just turn on your microphone, ask your questions. Otherwise, we can move on to the difference between ordinary annuities and annuities due when we look at FV. Okay, let me start sharing again. Let's go back to that Excel file. Okay. Let's copy these again. Control C, Control V. And in this case, let's say we change it a little bit. Let's say you invest originally 50,000, okay? In both of these investments, originally you invest 50,000, and let's say 5 years later you plan to buy something, so you're gonna need the money. So 5 years later is when you're gonna withdraw all of the future value. We're going to calculate this future value, so question mark here. But during the 5 years, you will also invest a little bit more every year. Let's say you're going to invest another 5,000 every year into this investment. That's going to be cash outflow from your pocket. So that's going to be a negative 5,000. And let's say you're going to do it every year. Something like that. Okay. So let me copy these cash flow payments over here so that we can have two timelines. Everything is the same about these timelines. Let's change the interest rates so we have different examples. Say 9% interest rate, 9% interest rate here. So everything is the same about these two timelines. The only difference is one of them involves PMTs that happen at the end of periods. Another one involves PMTs that happen at the beginning of the periods. So ordinary annuity versus annuity due. The question is, how much is your investment worth after 5 years? Okay. Control V. So clearly we need to calculate FV. Let's calculate the FV over here and see if there is any difference, see if we can learn anything about the difference between these two annuities. So equals FV, open the brackets, you know how to do that. For rate it's 0.09, comma, and PR is 5, PMT is negative 5,000. So I'm going to contribute more into the investment every year. Comma, PV is negative 50,000. Here I'm not going to ignore the rest of the hints. Comma, for type I'm going to hit 0 because it's ordinary annuity and close the brackets. So with this rate of 9% every year, including interest on interest, by the end of 5 years I'll have more than 106,000. So that's pretty good. How about annuity due? Again, equals FV, open the brackets, the rate of 9% per year, which is very high. That's why the future value is going to be pretty high. 5 years, PMT is negative 5,000, PV negative 50,000, and for type 1, because that's ordinary annuity, and the number here is going to be, again, bigger, okay? 109,000 and more, over 106,000. The reason for that is because each of these 5,000s have more time to grow, right? Look at the 5,000s in the first example. The first additional investment of 5,000 only has 1, 2, 3, 4 years to grow. The last 5,000 doesn't have any time to grow at all, right? So you deposit this 5,000 yesterday and today you already withdraw all of the money. So each of these 5,000s has 1 year less to grow compared to the 5,000s in the annuity due. For example, this first additional payment of 5,000 has 1, 2, 3, 4, 5 years to grow, as opposed to 4 years to grow for the initial additional 5,000 payment in the upper example. Okay, so that's why for annuity due, future value is going to be greater. And as we mentioned, for annuity due, present value is also going to be greater. Okay. So there is that. Let's stop sharing. See if you guys have any questions. Any questions? Okay. Let's take 5 minutes break. Okay, I need a bit of a break over here. See you soon. I'll be back in 5 minutes.